Ocean Engineering 117063 A comprehensive prediction model of drilling wellbore temperature variation mechanism under deep water high temperature and high pressure. Miao He, Jin Chen, Siwei Wang, Wenbiao Sung. School of Petroleum Engineering, Yangtze University. Outline, Introduction, Model Development, Mathematical Model. Solution Methodology, Model Validation. Results and Discussions, Conclusion, Acknowledgements. Deepwater hydrocarbon resource development has become an essential part of the global oil and gas resource strategy. The main regions where deepwater hydrocarbon resources encounter deepwater high-temperature formations. Research status of wellbore temperature modeling. Outline 2010 Merholt 2016. OCD 2019 played a significant role in drilling operations and considered to influence the wellbore temperature, drill string rotation, and torque and drag. The 2015 established a comprehensive temperature model for horizontal wells, the impact of various drilling parameters. Yang 2019. Miao 2023 established a rigorous transient heat transfer model mechanical energy at the drill bit. Zhang 2021 investigated the effect of changes on wellbore temperature distribution. Drilling fluid thermophysical properties. Yang 2019. RISFEED 2020 to study changes in annular temperature during deepwater drilling pipe eccentricity. How to accurately predict and understand the distribution and variation of wellbore temperature in deepwater drilling operations. Description of wellbore flow process of the circulating fluid. The drilling fluid is pumped into the drill string and flows downward within the drill string. The drilling fluid flows out of the drill bit and enters the annulus. The drilling fluid flows upward in the annulus and returns to the wellhead. Mathematical model, governing equations. 1 drill string area, 2 drill string wall area, 3 seawater section annular area, 4 formation section annular area. Mathematical model, the properties of drilling fluid and temperature and pressure. The correlation coefficient of WBM drilling fluid systems. Index, density, plastic viscosity, the variation of the density and viscosity with pressure. Solution methodology, finite difference method. Model validation. An experiment was performed into deepwater wells located in Zihu area in East China Sea and South China Sea. A comparison of the measured and simulated bottom hole temperature. B. Related error of bottom hole temperature. C. Comparison of the measured and simulated bottom hole temperature. D. Related error of bottom hole temperature. Results and discussions. Figure 1 the annular temperature profile under different heat sources. The temperature differences is the biggest, 10.66 degrees centigrade. Figure 2 comparison of unit control volume heat flux in different regions of the wellbore under different factors, eccentricity convective heat transfer, rotation hydraulic energy, rock breaking mechanical energy. Results and discussions. Figure 3 annular temperature with the different eccentric ratios of the drilling string. With the biggest temperature difference approaching 7 degrees centigrade. Fig for the variation of bottom hole temperature over time. After 66 hours of circulation, the bottom hole temperature decreases by about 2.6 degrees centigrade. Results and discussions. Fig. 5 the variation of bottom hole pressure over time. Cyclical variations in pressure due to the alternation of drilling and stopping pumping. Fig. 6 the variation of pump pressure over time. With the difference in simulation approximately 1 megapascal. Results and discussions. Figure 7 annular temperature with the different drilling speed. From 0 to 24.5 meters (R), the bottom hole temperature differs by 13 degrees centigrade. Fig 8. The variation of bottom hole temperature over time. With the bottom hole temperature difference of about 7 degrees centigrade. Results and discussions. Fig. 9. Annular temperature with the different rotary speed. The difference is 22 degrees centigrade compared to the scenario with 0 revolutions per minute. Fig. 10. The variation of bottom hole temperature over time, showing the temperature difference of approximately 5 degrees centigrade. Results and discussions. Fig. 11. The convective heat transfer coefficient varies with well depths. Convective heat transfer coefficient of the two-phase flow higher than that of the single phase. Fit.1. To the overall heat transfer coefficient varies with well depths. The drill string and annulus between the annulus and well wall. Results and discussions. Fig. 13. The variation of bottom hole temperature under different influencing factors. The liquid phase specific heat and circulation rate have the most influence. Fit.1 for the variation of bottom hole pressure under different influencing factors. Key parameters are circulation displacement and liquid phase density. Conclusions. A transient heat transfer model that considers various heat source factors such as the properties of drilling fluid at high temperature and high pressure HTHP, drill string eccentricity, rotation, and rock breaking of drill bit was established during deepwater drilling. A comprehensive consideration was given to various heat source factors, and further analysis was conducted on the heat flux distribution in unit control volumes across various sections of the well in response to these factors. Compared to drill string eccentricity, rotation and rock breaking of drill bit had a greater impact on the annular temperature. Drilling parameters were plotted against bottom hole temperature and bottom hole pressure so that the key factors can be identified. Further provide a theoretical reference for predicting wellbore temperature and extending to horizontal and highly deviated well. Acknowledgements. This paper is financially supported by the National Natural Science Foundation of China, now 51,900,034. Open Fund of Hubei Key Laboratory of Drilling and Production Engineering for Oil and Gas, Yangtze University, NOYQZ C202101, and the Open Foundation of Cooperative Innovation Center of Unconventional Oil and Gas, Yangtze University, Ministry of Education and Hubei Province, now UOT 2022-13. Thank you.